My name is Paul McLean. I'm the founder of Electrocell Systems. For the past year, we've been developing a marketing and organizational team, which I'm very proud of the headway we've made in the last year. What we do is we offer an innovative technology that addresses water, energy savings in a central chiller plant. We developed and patented this system to improve the efficiency of chillers and the way chillers perform on a daily basis. Over the past 15 years, we have perfected this piece of equipment and technology in the pharmaceutical arena. That is where we first started installing, that is where we first started getting results, and that's where we cut our teeth on this technology. In the past 15 years, we've gone through quite a bit of changes, but what we have right now is we have a system that is very, very efficient at saving both water and energy. We're at this point ready to take the system both national and global. We offer a modular, fully automated skid, and it's basically to replace existing side stream systems. If you have a side stream system, you know the maintenance and the problems associated with it. If you don't have one, you're wasting energy, and that's where we come in. We feel we fill that niche. For the past 40 years, I've owned and operated building automation system. We essentially install energy management systems in large commercial industrial facilities to save them utilities. So I went about developing this product from a control person standpoint, not from a filtration company or not from a chemical company, but strictly from a controls company. That's how I approached the product we have today. All chillers and towers, regardless of what they are or where they're located anywhere in the country, they all require a side stream filter. And the reason they require a side stream filter is every cooling tower will draw air in, they'll cool down the condensate water, and that's a good thing. The bad thing is they're sucking in all the airborne contaminants with that. That is dirt, dust, pollen, all airborne equipment that's suspended in the water. And what we want to do is we want to concentrate on that 1 to 5 micron, because that is the culprit that very few systems will even touch, and that's what's costing you all the energy. The particles that are 30 to 50 microns, they basically are too heavy to stay in solution. They drop out. The tower has to be cleaned periodically. I'm not concerned with them. I'm concerned with the small particles that accumulate over time and cost you all the energy. What we did is we have a unique system that will address both suspended solids and dissolved solids. The suspended solids, what I was talking about before that cost you all the energy, we're taking out 95% of those down to 1 micron. And there's nothing on the market that I'm aware of that can do that. We also address and control the dissolved solids with our technology. What I'm going to be doing in a moment is taking you back and showing you different components of the system. This is our system. This is a mid-range system. This would handle approximately 2,000 to 3,000 tons. We feed the system with the customer's choice. It can be 120, it can be 220, it can be 440, single or triple phase. You have to tell us what you want and we'll build it accordingly. Whole system is managed from a PLC touch color screen. This screen can also interface with a building automation system, and it is also web accessible. System is designed to drop suspended solids out and keep dissolved solids in solution until they're bled out. Let me go around the system and familiarize you with the components that we're using. Very easy installation. We have an inlet, we have an outlet, and we have a drain, and 120 amp circuit. Just because it's a 20 amp circuit, that doesn't mean what it's draw. This system will draw 2 to 3 amps. But we come in on our input, we go through a flow meter, we go through a conductivity meter, we go through our ionizers, which we're basically putting positive and negative charges on the particulate. We go through our vessels. Now these aren't filters, these are precipitators. There's a static mixer in each one, and their goal is to drop out anything that's 1 to 5 micron and above. But the bulk of what's in a system is the smaller stuff that we address. The system itself, once we go through the vessels, then we discharge into our manifold, and we hit our high voltage electrode, which addresses the dissolved solids. We keep them in solution. This was our first patent. We've been using this for 12 years. If you have a clean system, we'll keep it that way. If it is scaled up, we will descale it. The beautiful thing about all of this is any chemical system that you're using right now, the more suspended solids that are in the water, the less efficient the chemical system is. So by taking out a lot of these suspended solids, you're really enhancing your chemical program. We've been averaging close to 20–25% savings on water to the makeup on the tower, and we've been averaging 10 to 20 energy savings on the chiller. And that's across the boards. Typically we would put in a 500 and up system. However, we do make systems that'll do under 500 tons. They are basically, obviously, a much smaller scale than this. If you have a central chiller plant, or even boilers, hot water or steam, we address those also. The bulk of our business is chillers, but we also address closed loops. The systems are smaller, a lot less money, but they address the same needs and they work just as efficient. But what we'd like to do, if you feel as though this technology is of interest to you, we'd like to come in, we'd like to survey and put a proposal in front of you. It'll outline what the cost, the savings are, and what any service included would be. And we look forward to hearing from you soon.